Hello, everybody. I am Alex Ruane, and I am happy to be speaking to you today about the latest IPCC synthesis report, which I've been working on for many years and was released on March 20th, 2023. I am the co-director of the NASA Goddard Institute for Space Studies Climate Impacts Group, and also involved in large projects like the Agricultural Model Intercomparison and Improvement Project. And for this synthesis report, I was a core writing team member following my stint as a coordinating lead author in Working Group 1. So the synthesis report is the culminating report of the 6th assessment report cycle of the IPCC, the Intergovernmental Panel on Climate Change. In the 6th assessment cycle, there were 3 special reports, as well as 3 working group reports. All told, there were more than 800 authors participating, assessing more than 100,000 publications and addressing each of 300,000 individual review comments. That larger group was boiled down to a core writing team for the synthesis report that was 10 authors from each working group, as well as some additional authors from the special reports, the working group co-chairs and the technical support units, and then some contributing authors that we picked up along the way. But all told, this is more than 8,000 pages that we were tasked with boiling down to a synthesis report summary for policymakers that was about 10 pages with 7 figures. So I'll describe that synthesis report SPM today, and I'll use the figures as the guidelines along the way. So the synthesis report is approved by all of the governments that participate in the UN Framework Convention on Climate Change. So this was what we were doing in mid-March. We were in Interlaken in Switzerland, trying to get the approval of this report. And the summary for policymakers is approved sentence by sentence, with 195 governments needing to sign off unanimously. So here is a photo of some of the section facilitators, including Kate Calvin, who's the NASA chief scientist, and Dr. Ho-Sung Lee, who is the IPCC chair. So in the course of going through this report, there were things like contact groups where if there was an issue that had to be explained or better understood and clarified, they would break out into governments and the authors talking through that particular part of the report. So here I am talking with my colleague William from Canada, and the delegates that were leading this contact group from Ireland and from Kenya. And over the course of this week, through some very long nights, we were able to approve this report. Now, at times this required kind of high-level discussions. Here is the US delegation speaking with the Saudi delegation, with the IPCC secretariat. The nights got longer and longer. We were planning sessions between 11 and 2 a.m. and then started to just have no end. And many of us were up for 48 or 72 hours straight at the end to get this all approved on time. This led to scenes like this, people putting in tireless efforts and long hours to get all the way through this approval session. But in the end, we were able to do the final gavel and approve the summary for policymakers that we're sharing with you now. So the bottom line from this IPCC synthesis report is a warning, which is that the pace and scale of climate action are insufficient to tackle climate change. So despite all of the scientific evidence that we are assessing here, and despite the run-up of all of the IPCC assessments to date, the bottom line is that we are not tackling climate change at a pace and scale that will allow us to stabilize the climate system and avoid some of the losses and damages and the larger risks that we see coming. So the first figure in the summary for policymakers was one that I personally worked on. This was a figure where I led the team. And the idea behind this figure is to understand how what we've seen in the past is a prelude for what we're going to expect in the future. So the headline of this figure is that adverse impacts from human-caused climate change will continue to intensify. And the top panel talks about what we've already observed in terms of impacts and related losses and damages across human and natural systems. So on the things that we care about, we have seen changes to things like the water availability and food production, human health and well-being, cities, settlements, infrastructure, and then biodiversity and ecosystems. And the net balance in most of these are towards adverse impacts, although there are some things like physical water availability that show strong regional influences, reflecting the regional characteristics of the water cycle that's intensifying with climate change. Biodiversity and ecosystems are an area where it's very difficult to say on net on a global level if the impacts are adverse or positive. We do attribute specific changes in ecosystem structure, species ranges, and seasonal timing. We attribute those changes to climate change, but it's difficult to say, for example, if a predator moves into a new ranged area, is that a good or a bad thing? It might be good for the predator, but it might be bad for the prey. And there are many examples like that where we are seeing concrete changes that we are associating with climate change or attributing directly to climate change. And this type of disruption in the end is concerning. Now, of course, these system changes are associated with a long list of specific physical climate changes that are associated with human influence on the climate system. So as humans are putting greenhouse gases into the atmosphere and changing land use, we are seeing not just changes in global temperature, but increases in agricultural and ecological drought, increases in fire weather, compound flooding, heavy precipitation, glacier retreat, sea level rise, ocean acidification, and hot extremes. You'll notice here that this includes dry extremes, wet extremes, shifts in the ice, shifts in the ocean, and shifts in coastal hazards. These are all things, of course, hot extremes as well. These are all just samples of what Working Group 1 examined, but gives you an idea of the diversity of the physical climate changes that we are seeing. And now the challenge is to understand the vulnerabilities and the risks associated with each of these hazards as the climate is changing. So the final panel here is figure SPM 1C. And the headline on this panel is that the extent to which current and future generations will experience a hotter and different world depends on choices now and in the near term. And here we've taken the famous climate stripes that have been popularized by Ed Hawkins at the University of Reading, with each vertical stripe representing the global temperature for a given year compared to the 1850 to 1900 pre-industrial levels. So as you can see, in the early 1900s, there were some average years, some cool years, but this pattern of warming starts to become stronger and particularly intensifies in the recent 40 years. By the time we got to the 2011 to 2020 period, we were around 1.1 degrees Celsius warmer than in that pre-industrial 1850 to 1900 period. And this is something that is not just a global temperature change, it is associated with all of those other climate changes that we just looked at in panel B and all of the system impacts that we saw in panel A. And these stripes are also used in this figure in comparison to the typical lifespans and the experiences of people born in 3 generations. So those born in 1950 had a fairly small amount of climate change until later in life. And the last 40 years or so have seen a more dramatic increase in temperature. Those born in 1980, which happens to include people like me, have seen pretty steady warming over the 40 or so years they had before they reached 2020. The actual rate of warming for this person born in 1980 has been about 50% faster in their 40 years than this 1950 baby would have seen in their 70 years up to 2020. Of course, beyond 2020, we have to ask questions about what society will do. And that leads us to a discussion around future emission scenarios, which can range from very high down to very low. These bottom 2 being scenarios where there has been substantial mitigation effort to the point where we even stop and stabilize the climate system before the year 2100. However, these top 3 scenarios are ones where the emissions continue to be above net zero all the way out to 2100, and therefore warming will continue. And we can reach global warming levels of 4 degrees Celsius or higher. This is a future that is going to be determined by the societal choices that we make. And our models have run these simulations out into the future around those conditions so that we can understand the choices that face us as a society. And these generations, those born in 1980, The remaining decades, and there are many years to come, will be largely determined by the choices that we make. So here, these figures are split into segments, with each one representing a different scenario. And you can see that out by the year 2050, for this 1980 baby, there are some differences between the scenarios, but this is small even in comparison to those babies born in 2020. By the time they reach 70 years old, the difference between that very high emission scenario and the very low emission scenario is more than 2.5 degrees, which means it is more than twice the entire warming that has occurred in the globe since the pre-industrial times. If you reach out to these higher emission scenarios, the rate of warming is about triple for this 2020 baby compared to that 1950 baby for their first 70 years of life. So this future is really kind of in our hands in terms of what society will do. And this is not so much a figure to be doom and gloom as much as to indicate that we do have choices, we do have options, and the experiences that we might have had are not the same across the generations. And using your own personal experience to project the likely experience of future generations can be very challenging because it really is a different future. This figure has really caught fire on Twitter. Here's an example of a French translation, and I get a kick out of the fact that the French Le Monde newspaper has added a tie to some of these icons, and somehow all of the oldest characters are old ladies. And we've also seen this reach the younger generations in TikTok. Here we have Pedro Pascal, a famous actor, eating a sandwich while the big challenges of climate change are happening in the background. We've also seen things go to a little bit more extreme. I don't endorse this figure, but it's fun to see how people have taken it to their own perspectives. And here we have those born in 1950 saying later woke flakes to the younger generations as they kind of exit the world stage and leave a world that according to this artist is increasingly burning into the future. So it is interesting to see how people have taken the generational component of this to really understand the inequality across different generations, and also to capture the agency of what we can do to shape that future. Figure SPM2 is the next figure here, which is focusing on the larger question of physical climate changes as the world warms. So here we're using the same temperature scale from SPM1. And as the world reaches these indicative climate targets, these global warming targets, you can see the type of world that we might get in terms of the physical conditions. So we're seeing increases in the hottest day temperature for each point of the world. And you'll notice, for example, at this 3-degree world, that many parts of the continents are experiencing warming that is about 4 or 5 or even 6 degrees warming compared to the pre-industrial hottest day. That means that this hottest day extreme is warming even faster than the average. We're also seeing changes in the total column soil moisture, which is indicative of aridity or droughts. And you can see, again, the water cycle intensifying. So we have these strong drying areas like in the southwestern United States and the Mediterranean and parts of Southern Africa and Australia. We're also seeing that even in some of these places where there is an overall drying, we're still getting increases in the wettest day precipitation. This is a well-known physical response where warmer conditions allow more water vapor into the atmosphere. And therefore, when there are storms, they can tap into that larger water pool and lead to these high precipitation events. We also, of course, follow these physical climate changes and recognize projected changes in ecosystems and human health and other systems. Here is a figure SPM3 showing a risk of species losses as temperatures move outside of the historical range of what each species will look at. This is a study that was done with thousands of species, more than 30,000 species of birds, mammals, reptiles, amphibians, marine fish, benthic marine invertebrates, krill, cephalopods, corals, and seagrasses. You can see that they've really covered a large cross section, but of course there are many more species here, but the overall patterns are quite concerning in terms of risk of species loss. We also see that many parts of the world are going to have a dramatic increase in the number of days that are dangerous for humans to be operating outside for a long time. This can affect things like people like agricultural workers, construction workers, and many places have already adapted to this type of heat, or have at least partially adapted to this type of heat. But it's going to become even more prevalent and reach new parts of the world that are not accustomed to it. And these will lead to challenges for society. We also have shifts in food production impacts, using maize yield as one example, and fisheries yield. But here we'll zoom in on the maize yield because we're especially proud to see a study led by Jonas Jägermeyer as part of the AgMIP and EasyMIP intercomparisons. So there was a large team of AgMIP global gridded crop modelers that ran projections out into the future under a harmonized set of land use conditions and planting dates. And that allowed us to make these maps, which are unprecedented in the synthesis report SPMs, or even the working group SPMs. So to see this type of projection where we can not only show the emerging signal of maize yield declines over much of the world, but we can also put in the hatch marks where we can indicate the areas in the world where we don't have model agreement in terms of the sign of change. And that includes, unfortunately, many parts of Africa and South America where we just don't have great data to configure the models. And this is also a policy relevant message in the sense that we need to find those data and improve the models in those regions. Figure SPM4 is looking at increasing levels of risk using a set of diagrams known as the Ember diagrams. Here we're looking again at global temperatures as they increase from pre-industrial 0 degrees here out to warmer and warmer conditions, as we saw all the way back to SPM1. These Ember diagrams show the increasing risk that has been assessed as the temperatures go up. And we do this first and foremost around these global reasons for concern, or RFCs. And what's exciting about this is that we've done the same assessment in the previous 5th assessment report as we are now repeating in the 6th assessment report. And for each of these reasons for concern, the overall level of risk has been assessed to reach higher levels at earlier global warming levels. So let me say that again. If we were to look at something like this reason for concern, the global aggregate impacts, it used to be that we would reach this transition between moderate and high risk somewhere just before 3 degrees warming. And now the assessment is that that will happen more like 2 degrees warming. So not only are we seeing the world move further and further from pre-industrial conditions, but we are seeing evidence that risks are actually accelerating faster than we had previously thought. So the challenge really resulting from these first 4 SPM figures is that we need to cut emissions quickly and sharply to create a safer and sustainable world. To do that, we need to scale up practices and infrastructure to enhance resilience and cut global greenhouse gas emissions by nearly half by 2030. This is a substantial turn that is required of society because we have waited so long. Because the scientific warnings have been out there, but changing society or shifting towards more sustainable practices has been difficult to achieve. Because of that delay, our overall time to make these shifts ahead of these large risk levels, we've gotten closer and closer, and we've depleted more of the carbon budget. So that means we need to take action along numerous dimensions. So the next figures in the report really talk about what that will take and what it will look like. Figure SPM5 looks at the current or historical and projected greenhouse gas emissions and breakdowns of different greenhouse gas constituents. They note that under the currently implemented policies, the world is on pace to warm about 3.2 degrees Celsius. It could go higher than that depending on our uncertainties, as well as shifts in population or technological use, or the difference between what is a promised policy and what is actually followed through and kept promises. So this is the challenge. If we want to keep warming down to 2 degrees Celsius, we have to take this green path. And if we want to limit warming to 1.5 degrees, we have to take the blue path. To look a little bit more about what that looks like, the policymakers, the governments at the approval session requested this table, which shows the actual reductions if we want to limit warming to 1.5 or 2 degrees Celsius. And what you see is that the greenhouse gas emissions by 2030, which is only about 7 years away, have to be reduced by 43%. In 2035, this would be 60%, and by 2040, 70%, out to 2050, 84%. And for CO2, it's even stronger, a 99% reduction by 2050. And much of the messaging is around the developed world, the already high income economies, aiming for a net zero target of 2040, with the transitioning economies following by 2050. So the hope here, of course, is that mainstreaming effective and equitable climate action will reduce losses and damages for nature and people. And we have to take that action now. Of course, climate action is not just about the climate system. If we follow climate resilient development policies, we can actually link these actions with larger sustainable development priorities, which have numerous co-benefits. We've also identified multiple feasible and effective options that are available right now to reduce greenhouse gas emissions and adapt to human-caused climate change. The other thing that's important to note in this synthesis report is that we've taken the key messages from Working Group 2 and Working Group 3 and underscored how we can clear the path and improve the landscape for climate actions. So here's a figure that shows a little bit more about how we can select pathways that are more in line with climate resilient development, that links emissions reductions with adaptation and sustainable development to intertwine these into a larger set of development choices. When we're talking about clearing the path, we're really talking about making a broader set of enabling conditions that include things like more inclusive governance, incorporating diverse knowledges and values, and making sure that there is finance and innovation to support these types of shifts towards the future. There are several other things here that are listed, but I'll just emphasize that this is something that needs to be done in collaboration and cooperation between governments, the private sector, and civil society to empower both individual and collective actions. Of course, some groups are less able to create enabling conditions, but may be able to reduce constraining conditions. So we also talk about clearing the path by getting these things out of the way. And that includes, in particular, overcoming the lack of finance and the barriers to finance and technology that will allow climate action, or that have been hindering climate action in the past. So of course, when you put these together, we are looking at different options for the future and a continual set of choices that can move us towards development pathways characterized by many things that we are hoping to achieve. If we don't follow those pathways, we have reduced options, limited abilities, and limited opportunities to turn the path back around. And these confounding factors start to create vicious cycles that make it more difficult. One thing in particular to note is that as the warming increases, our ability to adapt is also increasingly limited. The final figure of the SPM looks at specific adaptation and mitigation options and characterizes them in major categories so that we can identify kind of where the science stands and the level of impact that different adaptation and mitigation options will provide. There's a long list here, and I encourage you to check that out. So finally, to put it all together, the major messages coming out of the synthesis report summary for policymakers, when we look at our past and present, we see that the current trends are incompatible with the sustainable and equitable world. The pace and scale of what has been done so far and the current implemented plans are insufficient to tackle climate change. As we look towards the future, we see that there are scientific advances that have already resulted in a better understanding of what the future will look like. And they have really demonstrated that that future, the heat and the difference in terms of the things that we care about in nature and human society, those all depend on the choices that we make today. So there are no plausible scenarios of the future that don't include some continuing warming in the coming years. So we do have to prepare for losses and damages and acknowledge that these have been and will continue to hit the most vulnerable ecosystems and people especially hard. Now, that said, the extent to which current and future generations will experience a hotter and different world largely depends on the choices that we make today and in the next decade. This is the time when we need to make these dramatic turns and shift our society towards a more climate resilient development pathway. There are tried and tested measures that can achieve deep emissions reductions and climate resilience. And the work now is to scale those up and apply them widely. So to put it all together, prioritizing fairness, climate justice, inclusivity, and sharing our diverse knowledges and values will lead to a more sustainable set of outcomes and support transformative change. And this is really the message of hope that comes from this report. The future is dire, but we can change that future by prioritizing climate actions and working together to allow us to take the best technologies, all that we've learned in all of the scientific studies that have been published around climate change, and shift towards more sustainable development pathways towards the future. So with that, I'll just say our choices that we're making now are going to reverberate for hundreds and even thousands of years. And everybody on the planet is watching what we will do. And there is a long future for us to think about, and those that we love who are going to be there to experience the ramifications of the choices we make. Thank you very much.